First, before we begin, I want to thank Ginny and Bractlet for sponsoring this tech talk. So today we'll be talking briefly about server-side rendering, SSR, and today's agenda will cover below aspects. First, what is SSR and how is it different from client-side rendering? We will also discuss what are the pros and cons of SSR. Then we're going to touch on a similar but different and related concept, which is server-side components. Then we'll talk about the implementation of SSR, which will mainly cover Next.js. Last but not the least, we'll also cover some case studies of adopting SSR in the industry. First of all, let's take a look at what is server-side rendering and client-side rendering. So on this page is a comparison of the application rendering process with two diagrams for the same application, but using client-side rendering on the left-hand side and server-side rendering on the right-hand side. Let's see how application works when it is a single-page application, namely client-side rendering on the left side. First, the browser sends a request to the server that serves this application. The server responds with an HTML file and a JavaScript bundle, which contains the code to render the application and add interactivity. The browser will then render the web page and dispatch an API request to fetch some data. Once the browser gets the data, it renders the data on the screen as per the JavaScript code. As you can see, both rendering and data fetching take place in the browser itself. The server has to send the JavaScript code for the entire app to the browser. This means the JavaScript bundle is going to be huge, and downloading it is going to take longer. This results in the first contentful paint, FCP, taking longer, affecting the user experience. In addition, the API requests from the browser go through public networks, and hence are going to be comparatively slower. So SSR mitigates these issues by rendering the initial page in the server itself. So if we look at the diagram on the right-hand side, after receiving the initial request, the server sends the pre-rendered HTML file to the browser along with the JavaScript code. When the user requests the app, the server will first fetch the data from the backend. Then it will render the page and send the HTML file to the browser. So unlike in SPAs, when we use SSR, the browser will be able to immediately show the web page. This reduces the time taken for FCP and consequently vastly improves the user experience. Moreover, since it is the server that fetches the web page, the user's internet speed is going to be immaterial. And the server can fetch the data a lot faster because the request goes through a private network. And here is a quite straightforward comparison of SSR and CSR in terms of the HTML source file we see from the same application using those two approaches. On the left-hand side, you can see the HTML file is quite empty when it's back from the server. It has the script needed and some basic stuff, but everything else is constructed on the client side. It's up to the browser, up to the JavaScript on the client side to create the HTML you see that's rendering the web application. On the right-hand side, this is a Next.js application which utilizes SSR and displays the same content as the app on the left side. The contrast is obvious. It's super long, and all the content on this app webpage is already here, completely done when it came back from Next.js, because your code is run on the server side. So naturally, this helps us to have a better idea on what are the advantages and disadvantages of SSR based on what we just learned. First of all, with SSR, your website's pages are immediately available for your users, even on slow internet connections. But for a client-side rendering website, users need to wait for the JS bundle containing the entire site to be 100% loaded, which can take a while on big websites. With a decent server, SSR can give you a great first contentful paint score, which improves the user experience. Second, the search engines don't need to run your JavaScript to read and index your content. CSR gets indexed as well, but not as fast as SSR. If your web app depends on traffic, it's better to use SSR. Also, it's hard to predict how long it may take your client's device to process JSON files and populate thousands of cells. On newer devices, it may pose no issue, but older devices can be brought to a halt. Server-side processing eliminates the guesswork while creating predictable performance and removing the processing power of a user's device from the equation completely. However, when using SSR, the web page will not become interactive immediately, and the browser needs to wait till it completes downloading the JavaScript bundle to add interactivity. Once it completes downloading, then the HTML page can be hydrated using the JavaScript code. So the user will have to wait for a while before they can start interacting with the app. This is going to result in a poor time to interactive TTI score. Additionally, once the browser loads the initial page, then this app is going to behave like a SPA. So if the user navigates to another page through a link, then the browser is going to render this page and send a request to fetch the data. On that account, the only real advantage of SSR comes at the initial page load stage with the FCP score, while TTI is going to be almost the same. Server-side components can solve this issue, which we'll talk about later in detail soon. Also, efficient caching is important for data retrieval performance, but SSR means each page's HTML is different. It's hard to cache this on a content delivery network. So users who load a page that hasn't been cached on the CDN will experience a longer page load. And last, SSR often needs a bigger and more powerful server to provide high performance than CSR. So as we mentioned earlier, there is a related concept called server-side components. And together with client-side components, they can solve the issue of SSR we just mentioned. And this is done by incrementally streaming the content of the app from the server to the browser. When the user loads the app, the browser is going to send a request to the server, just like what happens with SSR. The server is going to fetch the data from the backend. But we don't need to wait till we get the data from the backend. There are parts of the app, like the nav bar, sidebar, and the header, that we can render without the data. So the server renders these components and streams them to the browser. Since the server does not need to wait for the data, the FCP is going to be a lot faster in server-side components than SSR. The server needs to send the JavaScript code to render only the client components. Therefore, the JavaScript bundle size is going to be a lot smaller and faster to download. This means that the user interface can become interactive faster, reducing TTI. In addition, server-side components allow us to leverage the advantages of SSR throughout the application lifecycle, unlike SSR, which performs server-side rendering only during the initial page load. Also, since most of the components can be declared as server-side components, huge NPM packages don't need to be bundled with the JavaScript bundle that the server sends to the browser. So in conclusion, SSR and SSC are two different concepts. SSC can make the UI load become interactive faster. It also can have the server fetch almost all of the data score better on FCP and TTI than SPA and SSR, and provide a better user experience. Next, we're going to talk about how SSR is implemented, and this mainly concerns Next.js. Next.js is a framework built on top of React. It makes server-side rendering possible without any complex configuration. Besides that, it offers several out-of-the-box features which help developers to be faster and more effective. Next.js builds the HTML page at build time and serves the pre-render page from server to browser with minimal JavaScript code. And when page is loaded by browser, its JavaScript code runs and makes the page fully interactive. Next.js uses two forms of pre-rendering, with the difference being when the HTML is generated. So the first is static generation. Here, the HTML is generated at build time and is reused on every subsequent request. You can use built-in functions like getStaticProps and getStaticPaths. In case your data changes often, you can implement server-side rendering, where the HTML is generated each time a request is made. The function used is getServerSideProps. And this page has a short example on how to implement SSR in Next.js. We won't go into details, but you should use getServerSideProps only if you need to render a page whose data must be fetched at request time. This could be due to the nature of the data or properties of the request, such as authorization headers or geolocation. You can use caching headers inside getServerSideProps to cache dynamic responses. Next, we're going to talk about industry adoption of SSR. So which companies are converting to or adding SSR into their code base, and what are the considerations during their implementation? The first case study is on DoorDash. So DoorDash was faced with the issue that their homepage, which is the primary vehicle for their online marketplace success, was plagued with slow download speeds that were hurting the user experience and their SEO page rankings. And their solution was to implement SSR for high traffic pages. And they hope to upgrade a number of key elements, including first, enhancing the user experience by shortening page load times. Second, enabling bundle size optimization, as their existing CSR SPA was becoming difficult to optimize because the size of the JavaScript bundles had become bloated. And also to improve SEO. And during their move to SSR, they also noticed some common pitfalls to avoid. First, rendering too much content on the server can be costly and require a large number of server pods to manage traffic. So they only use the server to render above the field content or content required for SEO purposes. They also need to ensure the state between server and client components was an exact match, as discrepancies will result in unnecessary re-renders on the client side. So DoorDash customized Next.js and opted for the custom server approach to serving pages because it provided more flexibility in how they hosted their app with their existing Kubernetes infrastructure. And next is Atlassian. So Atlassian adapted their non-SSR friendly code in a largely legacy front-end architecture into a multi-tenanted service. Their front-end code wasn't necessarily written with SSR compatibility in mind, so their solution is to provide a compatibility layer that could adapt existing non-SSR friendly code to an SSR environment. And that is all for today's Tech Talk. Thank you, and here are my sources.